Good afternoon, everyone. Good afternoon, everyone. Myself Aditya. I am doing the topic of fcfs scheduling algorithm. Contents here are introduction, experimental setups, implementation steps, observation, comparative evaluation, and the conclusion parts. Coming to the introduction part, it has the three parts: what is CPU scheduling, what is FCFS, and the objective of the assignment. In CPU scheduling, we can understand that it decides which processor gets to use the CPU next. It aims to reduce waiting time and improve efficiency. What is FCFS? It stands for first come first serve scheduling algorithm. It is non-primitive, was run in order of arrival. It is simple to implement. Objectives are design FCFS algorithm, implement and test it, compare results across three datasets. Experimental setups. The language we used as C, tools as C, C++, and we can see there are three datasets which has its process ID, arrival time, and the burst time respectively. Coming to the implementation part, the algorithm first it creates the number of processes and gives us the input section for arrival time and the burst times. Sorts the process by arrival times. Initial the starting time as 0 for each process. If CPU lighter, jump to the arrival time, update completion time, calculate waiting and turnaround time, display table, and Gantt chart. Uh, Flow chart says that start input number of processes, input arrival and burst times for all processes, sort the process by arrival time, set time equal to 0 for each process in a sorted order. If arrival time is less than arrival time, compute the waiting time and the turnaround time. All processes are completed and the end. Code and the output. We run our program in this C++. It for address section it has studio.h, which it processes input and output sections. We created a structure named processes which contains process ID, arrival time, burst time, completion time, turnaround time, and the waiting times. We give a number of processes 3. It starting print as FCFS scheduling simulator n equal to 3 processes. Input section. In this section tells us input for a user to input the arrival time and burst times one by one. It automatically gives us process IDs by them. Next, this loop sorts the arrival time sorts the process by based on their arrival time. This is the main part. It calculates the completion time, turnaround time, and the waiting times with the respective formulas. This section creates a table and table where it has the process times, turnaround time, burst times, arrival time, completion time, and the waiting times. Between one and table. I also calculate the average waiting time, average turnaround time, average number of context switches. Execute. Run. Let's take some example. Let's take arrival time is 0. Burst time for P1 is 2. And for P2 1. And test 3. For P3 is 2. And test 4 has 2 and the burst time is 4. It gives us a respect table. You can see that arrival time, burst time, completion time, and turnaround time, and the waiting times. It also gives the average of the waiting time and turnaround time, and also number of context switches. Coming to the observation, you can see the respective three datasets results in a table format: process arrival time, burst time, waiting time, and turnaround time, with their respective outputs as average waiting time and average turnaround time. Comparative evaluations. There are three datasets. Average waiting for dataset 1, average waiting time was low and turnaround time was low because similar size was well. For dataset 2, average waiting time and turnaround time was medium. Order impacts results. For dataset 3, average waiting time, average turnaround time was highest. Remarks the ideal CPU, large burst gaps. Summary, you can see the FCFS works best when arrivals are predictable and burst times are close. Performance drops when arrival gaps or large burst differs exist. Conclusion, we can say that FCFS is simple and easy to implement, works well for batch systems, suffer from conway effect, not suitable for real-time tasks. Bold introductory scheduling technique. Thank you.